Oh.
Yeah, but then.
Sorry.
Yeah.
Okay. Oh, sorry for the online participants. They couldn't hear me, but maybe they had some extra rest. So, going back to the general steps. So first, to get a 3D model, then to convert it into generally in an STL file, then you have to use a slicer program, because as you can see in our 3D printer, the main technology is about that you would like to print your object layer by layer. So the 3D printer needs information where to put the layer, where to put material in each layer. So the slicer program main activities is about to generate a special file format which contains this information where to put the material in each layer. And of course, the last step will be to 3D print your model, which is maybe the most interesting part, but only the last one. Before that, you need lots of knowledge to ensure that your 3D printed model will be of real functionality you need. Okay, now we will learn a bit more how to get a 3D model. Of course, we are smart enough, so maybe the first thing you should consider to look for a 3D model on internet. So you can download it, you can check whether somebody has already designed what you need. So you can visit several web pages. There are really several web pages, for example, Pinshape or Thingiverse, where you can access very nice 3D models for free. And if you design something, you can also upload and share your model with the community. I think this is a very smart first step to check whether is it already available or not. You can spare lots of efforts and so on and so on, and you can also inspire from these models when you need something new to design. So I think this is a very smart first step, just to check whether it already exists or not. Okay, what happens if it doesn't exist? Or let's say you have one copy of your object, the second or the third one broken, and you need to double or triple your one single model. Well, when we are talking about documents, it's quite easy that you will copy your document. In case of a 3D printed object, you can, for example, use a 3D scanner to capture the geometry of the object. You can see it again, lots of time to design, and use a 3D scanner to substitute the steps of designing your object, and then you can simply print your object. Of course, you need a 3D scanner, some kind of investment. But the good news is that it is not mandatory, because, for example, if you have an Xbox or Kinect device, they can produce you depth information. So if you make some programming, some coding, then you can use these devices as 3D scanners. Or, for example, Autodesk Recap 360. This is also a free application which can be used to convert a series of photos to a 3D model. So finally, 3D scanning, another option, and well, probably a very smart option again. What happens if we cannot download and we have no sample object which should be doubled? Then if we need something brand new thing, what we can do? Well, we have to design. To design, you need a software, of course. In this slide, you can see 6 different design software products, and they all free. That's good news again, that you can use all of them for free. TinkerCAD, it is much more popular and attractive for general people because it is not only free, but it runs in a web browser. So you don't even have to download and set up on your computer. You will learn the basics of work with TinkerCAD this morning after my introductory lecture, but you can use Blender for design 3D models, or FreeCAD, or OpenSCAD is also attractive sample application, because in OpenSCAD you can use scripts, so you can make coding. If somebody prefers doing coding, then why not to use, for example, OpenSCAD? Okay, these are only 6 sample applications, 6 open source or free application, but also there are more professional and proprietary software products as well. In the next slides, you can see proprietary softwares mainly. SolidWorks, it can be used really for everything. So if you would like to design anything, I'm sure that SolidWorks can be used to design what you need. But more 3D, Rhino 3D, also a very nice 3D modeling software, Cinema 4D, Maya as well. Concerning SketchUp, in this case, there is a free web-based version as well. So, wow, as you can see, you can really find the appropriate software you need to 3D design your object. Okay, so let's suppose that you have already designed your 3D model. We will skip some steps. I won't talk too much things about the different options you have to set before 3D printing, but I would like just to highlight the main principles of one 3D printing technology, which is called fused deposition modeling, in brief, FDM technology. You can see here in this classroom an FDM 3D printer. In this case, the raw material is called filament. This is a so-called filament-based technology, which means that you can see that there is a filament, a thread of filament, which is threaded in a pool and led to the so-called printing head. This filament will be heated up to approximately 250 degrees, which means that this filament will be liquefied. This makes it possible that the printing head will put the material on the appropriate locations, and after completing this deposition of filament on the appropriate positions, the next layer can be built. Is there anybody who haven't seen an FDM printer before? Okay, then please stand up and come here to see, to have some experience how it works. Okay, just come here. So this is the raw material. The printing head is there. There is another which diameter is about 0.4 millimeters. It is liquefied, so the material is quite hot when it leaves the printing head. But as soon as it leaves the printing head, because we are, also the 3D printer works at the room temperature, and there is also some built-in fans, immediately it will harden, so the temperature of the raw material will be decreased dramatically, which means that when the one layer is completed, in this case the printing head will be up the width of one layer, and the second layer or the next layer can be started to build. Okay, this is the basic principle of this FDM technology. This is not the oldest technology, but this is the most popular because it is quite cheap. And concerning the size, this is a desktop size, so it is really easy to take with you, to take into a classroom, and so on and so on. So nowadays, lots of universities, high schools, or even elementary schools can have an FDM FDM 3D printer. The maintenance of these printers is really not too quick, so not too expensive, so it is really a very popular technology for demonstrating, for learning the basics of 3D printing, and to promote STEM studies and so on and so on. In this case, it's hard to realize what is currently printed because we have got this transparent colored filament. But maybe you can see, if you just come closer, you can see that something has already started. So by the end of today's workshop, we will have something on the building plate. And there is an SD card. So you can see here the SD card, which contains the information the 3D printer needs. After using the slicer program, a so-called G code is generated. The G code is copied into the SD card, and this information is enough for the 3D printer to make the work. If you are talking about FDM technology, there are more professional versions as well. For example, if the printing volume is closed, then lots of other types of material can be used. All of them will be some kind of filament, but it can contain, for example, some kind of metal, some kind of antibacterial things, and so on and so on. So there are really professional versions as well, but for household objects or for demonstrating, this kind of machine is really perfect. If there are any questions now, just ask.
How expensive is this printer?
Well, these printers are not expensive anymore. I think, well, I don't know exactly. It must be, I think, under 1,000 euro. Yeah. And if you would like to spare some money, then you can buy it in parts, and you will assemble it. And in this case, it can be 700 euro or so. If you make a search on internet, you will find very cheap 3D printers as well. But you have to take care, because some of them seems like a 3D printer, but they won't be accurate, and so on and so on. I can recommend, for example, Prusa. Josef Prusa is a Okay. A Czech inventor of a 3D printer. He has a very successful company in France. They also sell 3D printers with FDM technology. And for example, from Russia, you can buy a 3D printer in parts. And at home, your first task will be just to assemble the different parts. But the quality of Russian printers are really very good. And while it's affordable, the price is quite affordable. Okay, any other questions? Now or later? You can ask anytime.
So you wouldn't buy like, let's say 300 euro printer, because I know there's like many models that are 300. So.
Some kind of risk. Of course, I haven't tested all of them, but I have already heard, yeah?
I was looking for 250 theory and free, and I think everybody also in our school here with printers and data.
And they are good.
Yeah.
Okay, what I thought, take care.
Yeah.
That's all. Because I haven't tested all of them, of course. But I have already heard stories that somebody bought, wow, it was so cheap and so on and so on, and after 2 months, okay, I gave up.
I saw also a little bit for 100 euro that it was like only one leg.
Yeah, so my only piece of advice was take care.
Can I ask the cost of the circle of the material? Like the material?
Maybe this is also PLA. As PLA. I think that this is PLA is the most which company you buy. It can be quite expensive and it can be quite affordable. Well, in Hungary we buy one full, about yeah, about 13 euros or so.
Okay.
So it's not too expensive.
Can you do a lot of things from that?
Yeah. When you use the slicer program, which will generate the code, you will have a calculation about the printing time, because usually it is not a fast project, not a fast process, and it will calculate also how many grams raw material you will use. So, well,
And this one has how many grams?
usually according to
1 kilogram.
1 kilo.
Okay.
And if you touch this, for example, this part, it is not so.
Usually they are quite light.
Yeah.
So you can print so many things from 1 kilo.
Okay, cool.
But if you use a service, a 3D printing service, they are usually quite expensive. But you know, they work for benefit. They would like to get money.
And what if you run out of filament during the printing? Like, does it realize like straight away? Is it precise enough so it can continue with the printing? So the whole project is not scrapped?
While
There are parts of printing should not quite. That's pausing and sometimes it's pause accuracy.
okay.
And what about like more complicated mathematical models? Like this would be simple, but like a Mobius strip, would that be possible?
Well, technically, this is beyond the objective of today's lecture, but we can talk about later. Okay, don't forget.
And how sustainable is printing?
How's the very good question?
bottles
How sustainable is 3D printing? Well, PLA, very good question anyway. Thank you. PLA is a biodegradable material. So it sounds great that if you print anything from PLA, then it is biodegradable. Okay, in certain circumstances. Okay, so not in any way, but more than nothing. There is a very heavy debate about how sustainable 3D printing, and what you have to remember that FDM is only one technology. There are several basic types of technology, and the used technology will determine the raw material. For example, we cannot 3D print anything with an FDM 3D printer from metal or from resin. But there are other types of technologies which can be used, titanium, for example, or resin, or gypsum, and so on and so on. And sustainability will depend on, for example, what kind of raw material you will use. Okay, so what? I don't remember exactly, maybe 1 or 2 years ago at this workshop, my lecture was about sustainability of 3D printing. If you are interested, I can share my presentation with you. But what is good point in printing with PLA, that unused material or broken object could be collected and again create filament from the unused material.
But you said could, so it's not guaranteed.
For example, in Hungary, I have no information that anybody collects these rubbish. I have already seen advertisement on internet in Western Europe that somebody, some companies offered this opportunity. Please collect, I will get it, and maybe I can give you some rewards or something because you have collected some amount of raw material, but in Hungary it doesn't exist. That's all what I can tell you. Or theoretically, it could be done, but I don't know whether, because you know, sometimes if you can just read something on internet, there's an ad, I cannot check whether it is a real offer or not. So theoretically, it could be, but who knows? Okay, so now probably you know the basics of how fused deposition modeling works, and as you can see, the basic 3D printer can use only one filament, which means that theoretically you can 3D print something only in one color. Okay, you can see here also lots of different objects we have printed during last years, and it can be used for so many things at schools to demonstrate different things and so on and so on. We have also some objects here, and as you can see on the slides or on the desk as well, sometimes we can use more than one color. The question is, how can we use more than one color in one object? Well, an FDM printer can have two heads. So instead of one head, it can have two heads. In this case, its professional name is two-headed FDM printer or something similar, which means that you can have two different filaments, and this will make it possible to exchange or to mix the colors in one layer. Okay, you can see some printed objects there. The principles of 3D printing finally is exactly the same. There is a built-in switch which will control which head should be used at the given location. So finally, you can mix two colors in one object, but oh no, yeah, we have no pictures there where more than two colors are used, but we will talk about it a bit later. And there is one more very good point about two-headed FDM printer, and this is that you can use the second filament as a special support material, because sometimes we need some base of raw material as well, because you can imagine that, for example, if you have a closer look at this object, its geometry is quite complicated, and it couldn't be 3D printed without a support structure. Originally, the support, the same material is used, but the structure will be much lighter, and after finishing the 3D printing process, you can just remove the useless part, and of course you will generate some kind of waste in this way. But if you use the second head to use this water dissolvable support, then you can spare some work, because after finishing the 3D printing process, you have to just drop your 3D printed object into a glass of water or tank of water and wait, and the support material will dissolve, so you don't have to bother with this removing process, and you won't damage the surface of your 3D printed object, I'm sure. So if you have got a two-headed device, then you will have a larger flexibility for using more than one color, and also for using water dissolvable support. But what happens if we don't have a two-headed FDM printer like here, but still you would like to have colors in your object? Well, the smartest solution is to use so-called rainbow filament. Quite easy, quite nice. Of course, you cannot control the ratio of different colors and so on, but still you will have quite nice, quite attractive objects. Okay, why not? More than nothing, and quite easy. Okay, the second option is a bit more demanding, that you can stop the printing process and you can change the filament. Okay, so the same, you will print one object, but you can use different colors. The key concept is stop the printing, exchange the filament, and go on. In this case, basically, there are two different design approach. The first is can be seen on pyramids. In this case, how to say, you will 3D print the original object, and well, the secret is revealed because you can see that different colors are used in different layers. So it is easy to capture how it was done, because in this case you cannot mix the colors in one layer. If you have a closer look on the right hand side picture, then what is the main difference? That there is no flat surface on the right hand side. I would like to show you, for example, these letters. You can see 4 different colors. I will give it to you, but if you touch it, you can see that the width of the letters are different. So this technology, this second technology, or the logo of our faculty was created with this technology as well. So in this case, when you will design your object, you have to think it in advance that the width of different components should be different to ensure that the last color won't obscure the previous color. Okay, so this is a quite nice technology, but you have to keep in mind when you are creating the design. During the modeling, you have to, yes, thank you. These are the main steps with this multicoloring with a single extruder. When you plan your model, you have to design the different width of different components you need in different colors. Okay, this is a quite nice trick, quite useful, and wow, I just give you to touch and to feel the difference. Of course, in this case, you won't have a flat structure, but you don't need it anytime, every time. So in most cases, it's not a problem, and you can have colors in your object. Yeah.
Here you should compute with the layer height. On the table you can see green samples. They are in one layer. Okay, it is 0.2 millimeters.
This is the typical layer height.
Very thin. It is the usual
layer height
in this technology. Okay, so
0.2
when you compute
millimeter.
different levels on your design, then you should compute with the layer height 0.2 millimeters, and you can touch it in the green sample. Okay.
Yes, thank you very much for your comment. This is very important because when you make your design, you have to keep in mind that a typical layer height is usually 0.2. You can feel what does it mean in reality, and of course you have to take into consider that this is the minimum you need between the different colors to have the opportunity to use different colors, but probably it is better to have at least 2 layer height between the different colors. Okay, and well, that was the last slide about the theory. Of course, I could talk till Friday afternoon about 3D printing for you, but probably you don't want to listen to boring lectures anymore. If there is now any questions, You are welcome. Yep.
You said that sometimes you need a supporting structure
Yeah.
with the base. Is that like an automatic situation, like a software generated? Like, does it know, like, I want to print a ball?
Okay,
Like,
I can ask. Okay, okay. Very good question anyway. So, the first phase that you have to 3D print your model. During this phase, if you know the basics of 3D printing, you can use technology to try to eliminate the need for support structure. You don't have to plan the support structure because the slicing software will generate. Concerning whether this is automatical process or not, well, it depends on you and it depends on the slicing software itself, because well, the easiest way that you just check a checkbox, please use support structure where it is needed. There are slicer softwares where you can control very strictly that, okay, here I don't want to use, here I would like to use, although the slicing software doesn't recommend, but I would like to use here because I think that this is a risky place. So in the slicer software, you will have the option to tell the software whether you would like to have or where you would like to have support structure. For example, yeah, in the case of this cap, it's trivial that, for example, you have to, this handle, the upper part, the bottom part of this handle needed a support structure, because you can see that, well, the lowest point otherwise would start in the air. So definitely here there was some structure. But you don't have to plan it in advance because the slicer program will generate according to your settings. Yep.
Can you also make the object smooth? So because right here you can see how it goes, like in the graph. Can you also print it smooth?
Well, when we are talking about smoothness of FDM technology, okay, I don't want to tell about all of them now, but if you would like to, no problem. So if we are talking about FDM technology and smoothness, we can talk about two different things. The first is that according to the Z coordinate system, the smoothness will depend on the layer height. The typical layer height is 0.2 millimeter, which means that you will build 1 millimeter out of 5 layers. It's not bad. But of course, you will be able to feel. You can hear. Okay. The smallest layer height is 0.1, which is better. And if you still don't want to feel the layers, you can post-process. So if you post-process, you can eliminate this feeling along the Z coordinate. And when we are talking about the XY plane, in this case, the smoothness is determined by the diameter of the nozzle. Okay, and the diameter of the nozzle is 0.4 millimeters, which is worse. Okay, so if you put, anyway, very good question. If you put any ornament on a surface which is parallel with the XY surface, then the smoothness will be determined by the diameter of the nozzle, which is 0.4. So if you need nice decoration, nice pattern, it is better to put or to change the orientation of your object, that the decoration should be parallel with the Z coordinate axis. Okay, if there is no more question, then Ildiko will go on and you will learn some steps how to work with TinkerCAD. So please switch on your computer, get an internet connection.
So you can see the link to the application here, and this is a screenshot of the site. So you should sign in or create account here. So it will work with Google account and Apple account, or you can create another
a new account with any kind of
with an
email address.
for example. Okay, so we will start it.
Are we going to join a class or?
No.
Okay.
And parallel with this, the presentation in PDF format is uploaded to the
Teams.
Teams.
No, sorry.
Teams. Teams, yes, in the general
General channel, yeah.
general channel, you can see the link and you can achieve the PDF format because there is a short description about TinkerCAD modeling, how to use this application, but I would like to show you on the screen. But there is a description, is a help for you for the usage of this application later and time later. Okay, so I will switch to
your account.
To my account.
So please sign in, create an account for yourself, and you will start maybe your first 3D design with Ildiko.
So here, yes, and at first I will switch to English. Here, on the bottom of the side, you can see this is an Autodesk text, and here you can switch to English. Okay. And sign in. Personal account. I must check. What is it? What is the? I need a. Okay. My account. Okay, and it is my account, so I have different designs here in this folder in the cloud. So it is a very good idea in this application. The storage of your designs are here in this account, so you can achieve your designs from anywhere with an internet connection. And when you start the TinkerCAD modeling, at first some tutorials wants to start, so you should skip it. And after this, here this is an empty for you. Okay, so by recent design and create a new design, and here there is nothing. Okay, and you can see the lessons later and time later. Here there are some tutorials in this application, and here you can see you can create 3D designs, or you can create circuits. I am no engineer, so I have no idea how to use it. So this is a very good way to start engineering life. And there is a code box. This is so close to the coding in 3D design. Okay, so there are different ways to create objects here in TinkerCAD. And here you can explore the gallery. So your work or your design can be shared with the others. So in the gallery you can see the shared objects from the users, and there is a blog, and there is the tutorials as well, and so on and so on. But at first we will try to create a new design. It is here in this blue box. When you click here, you can see the workspace of this application, and it is a user interface which is similar to the other 3D modeling applications. So in the main area of the screen is the workspace. And here you can see a horizontal work plane. It is a blue part here in the middle, and it demonstrates the horizontal coordinate plane, X, Y, and all the objects will be put on this plane. And if you see the left part, there are some navigation tools here. I will show you. And yes, right. And on the right hand side, you can see some initial objects. They are geometrical objects, but they will be the components of our design. So when we imagine an object, we can split to the geometric object, and based on this idea, we can create a complex shape. And this idea is common to the other 3D modeling applications. With the components, we can create Boolean operators, and we can create more complex objects. In the TinkerCAD, the union and the difference of the object is supported. That is the way how to create this one. And the common part of the object is not definitely defined. So it can be created, but it is very complex idea how to create them. So the suggestion is to avoid the common part of the object. Okay, design the other way. And in some words about the object. So here on the right hand side, you can see, and this is a gallery, for example, about the basic shapes. So here you can see a cube. This is the box in this language, or a sphere, or cylinder, and so on and so on. For example, when you want to use one of them, you can move it to your work plane. So it is a drag and drop. It is a very easy to use this application. It is a box, and if you check, there are some different settings. They are available in this pop-up window. Here you can see there is a radius. It is a new information about the boxes. But you can see the dimensions of the object can be changed with these sliders, or can be changed with the handles. So we have a cube, or I have a cube on the work plane, and I will show you how to use the navigation tool. So when you rotate the wheel of your mouse, then you can see, you can zoom in and zoom out. Okay, so when we want to create a very small object, or we wanted to check something, we should go so close to the object. And for example, when you push push the right knob of your mouse, and parallelly with this pushing, move the mouse, then it is flying around the object. Is the idea. You can rotate your cube in any other directions, so you can see different sides of the object. It is a flying around the object, okay? And for example, when you rotate this orientation cube on the left corner, you can rotate it with pushing the left knob and rotate your and move your mouse. It is a similar flying around. And if you check, there are some named views of the object, so you can navigate it in this space. So where is the top view, where is the side view, front view, and so on. So this view helps you to identify your position in the space. Okay. And parallelly with this, This is the home view, this first small icon. You can go back to the starter position, and for example, plus and minus is similar to the rotation of the wheel. And you can switch between the perspective view. Basically, it is the perspective view of your object. So when you see the border of the work plane, but you can switch to the orthographic view. It is the astrometric view with the other name. For example, when you want to check the top view, exactly the top view of the object, this orthographic view with top view together creates the perfect top view of the object. So when we want to combine the elements, it will be perfect for us. So I will switch to the perspective view and I will rotate my screen. And here I would like to, the panning, yeah, it is not. Basically the panning works with pushing the wheel in this computer. It is not supported, maybe. Only flying, yes. Okay, maybe it will work on your computer. When you push the wheel and move the mouse, then it is a panning. It is only moving the screen, but it is not working in this computer. Okay, so it is a cube. It is not selected at this moment. And when you click on the surface, it is selected. If you see, there is a light blue border around it, and the handles are presented. So you can see different handles around the object. And for example, when you try to move a white handle, for example, on the bottom, you can see you can change the dimensions of the box. So basically, all objects can be changed, can be smaller or larger with these handles. And if you check the label, the TinkerCAD uses the dimensions with 2 digits. So if we have not exactly the integer numbers in the dimensions, so not enough in the millimeters, you can click on the label and you can type different real numbers here with 2 digits, and you can define the dimensions very interesting. Okay, and for example, when you use the black handles, only exactly 1 dimension can be changed. Okay, white handle change 2 horizontal dimensions together, and the black handle is can be changed only 1 dimension of the object. And you can see a white handle, as I have no effect here. So when you see a point, a midpoint or center point of the top, it is a white handle. You can change the tall of the model with this. Okay, and there is a label, and you can click on the label and you can type directly the dimension. Okay. So I think it is very impressive because we have.
How can I move the object into the air?
Yes, it will be the next. Yes.
Okay.
So everything is put it on the work plane. Okay. So when you want to move it in horizontal directions, you can drag and drop and move it on the work plane. On the white arrow can be used again. If you check, it is not a limitation of your work plane, this light blue object. So the horizontal moving is easy. And if you check, I will rotate it. That is a small triangle, black triangle, which is floating in the air above the center point of the top plane. With this handle, you can change the gap between the work plane and the object. Okay, so I will close this box because I have no penny. So if you see, my box is in the air, and this shadow helps to identify this floating. And when you move this handle, you can see the distance between the object and the work plane. Okay, so definitely each object is standing on the work plane, but you can move them to up or down. So for example, it is not up, it is a down. I will rotate my screen so under the water. Okay. And the distance is this is a label. You can type it directly if you have given dimensions for this distance. Okay. And actually, I will open this. I try to move my object. Okay. So far from here. Okay. So here, in each object has different roles in the designing steps. So a cube or any other object can give a material to our design. The colors means this step. So if you check this red color, but I can change it. So the solid object give a material to your design. So it means when you want to change the color of the object, it is a part of the design step. We have the user, but basically the color not depends the color of the printing. Okay, but my students use the similar color to their design. If they want to print something in black, they design it. The design is black in TinkerCAD. But here it depends on the filament color. So if we have natural PLA here, so the design color is can be different. Okay, and when we switch to, for example, it will be the yellow. Okay, and when you switch to the whole roll, then it will be gray striped and translucent cube. This cube is for removing the material from our design. Actually, there is nothing around it, so from the air it is not perfect. But for example, if I move here a cylinder, and this cylinder has a common part with the box, then this box can cut my cylinder. Okay, so it means the common part will be removed. You can try it. A box or an object which is solid and an object which is whole, and move them so close to each other, and they need a common part. Then we will select all of them. So the Control A select all the design elements on your screen. But basically, if you have more components, we don't want to use all of them. So click anywhere, and for example, pushing the Shift knob on your computer and click on the surfaces of the object, you can select definite number of components, or the other way, close window or create a window around it. Okay. It is similar to the Windows navigation. Okay, then they are selected. And if you check, the selected components has a common border. If you see these blue colors around it, and they have a common bounding box, and the base of the bounding box is here. Okay, so they are together. And here on the top, there is an icon row of the icons, and here this one is a group. The group is create union of the objects. So here, when you click on this tool, then you can see the result. I will rotate it. So if you check this result, my box was in the air and has a common path with my cylinder, so the cutting was realized and the common path was removed from the cylinder. Okay, so when we create the complex shapes with the union and difference, we can get more complex ideas. Okay, and anytime later, this complex object can be ungrouped, can be split to the components. So the other icon is ungroup. So here you can see the components again. You can change it, or for example, the dimensions, or the other settings can be changed, and you can do it again. And for example, when we want to create the union of the objects, we need 2 or more solid objects. So my cube is not solid, so I will switch it to the solid object, and then I will group them. Then they are create the union shape. So the volume of the objects can be added, and the faces are more complex because some faces are preserved from the original object and some of them was created with a new shape. Okay. And I will split my design because of some interesting things. For example, for the cylinder, there are 3 sliders. Maybe for the cube was 5 or more, I don't know exactly. So when you use the sliders, you can see the changing of the basic shape. So for example, here there is a side. The default number of the sides around the cylinder is 20. You can improve it with the slider, and the maximum is 64. And if you check your design, then it looks more smoother in the surface. Or when you use this slider, the minimum number is 12. You can see basically it is not a cylinder, it is a pyramid with special polygons. So you can create changing with the sliders. It depends on your idea. I will move it to the maximum number, and for example, bevel and segment, and it means when you there is no opening, so I will move it to the screen. Okay, so the bevel is so close to the engineering life. The engineers can design something. Sometimes the sharp edges of the object will be removed. The removing has 2 ways, chamfering and filleting, and this bevel is a combined them. So actually it is a chamfered edge because the number of the segments is exactly 1, and when you improve this number, you can see the other possibilities. It is so close to the filleting. Okay, so this bevel combines the chamfering and the filleting, but we use this application through the browser, and there are some limitations for the user. So for example, the smoothness of the object is not so fine. Okay, always, basically always we get polyhedrons in our design. Okay, so basically it is one of the limitations of this application, but it is a very good application for the starters. Okay, so for example, I have a cylinder, and if you check, when I change the dimensions of the cylinder, I can change the base of the cylinder. So Basically, we have a circular cylinder, but here the base is an ellipse. So when you check the possibilities, there is no geometry content, so there is no radius definitely written here. We can change the object with their bounding box. This bounding box is not illustrated in this application, but we should compute them, or we should imagine them. For example, with the base, and here on the top, there is a center point. Okay. So I try to move it. Okay, and for example, I will drop it to the screen, and I would like to show you how to rotate your model. So sometimes we need to rotate our design elements or components because basically they preserve the original coordinate system and or follow the directions of the coordinate system. So if you check, there are some double arrows here around the object, and if you check, it is a tool for rotation, rotate the object. So at first I will show you the rotation around a vertical axis. When you move this handle around the object, you can see the angle of the rotation, positive or negative directions. Basically, the axis of rotation goes through the center point of your object. Okay. So when you see the result, it was rotated, then you can see the new bounding box around the rotated box. Okay. Or you can use the other handles, and basically you can rotate your object in different directions. So be careful when you create a rotation here, because then you here in the designing step you can go back with Ctrl Z, or here with this undo tool. But anytime later, this information, the angle of the rotation will be lost, and so you can use this rotational tool carefully. Okay. So yes, and now you can see we are in the basic shapes. It is a collection of initial figures, which looks so geometrical shapes. But if you open the possibilities, there are some other elements. Some of them are not so familiar to the 3D printing. So when you check the components with vehicles or with creators and so on, characters, maybe they cannot be printed with FDM technology. But there are some shape generators. Okay. So when you check these samples, they look very interesting. Create the spring or part of torus or any other shapes. They are the feature, but all of the design components can be available from the maps of Europe or any other countries or parts of the world. And for example, the brick wall and the house with some garden part, or you can check more objects. For example, the text elements are available here as well, so different type of the text can be created. So for example, this is a text which is around the cylinder. You can see the curved text, you can change it. So for example, it is around the cylinder. You can create on the surface, for example, on the cup. Okay, so the text element is lying on the work plane. You can switch the other. Okay, it is a remix of the original text element. So here there is no way to change the. Yes, the letters are create a complex element, so we cannot split it. But there is a text element here, design starters, and letters and numbers. No, it was redesigned and I lost some maybe in the basic shapes. Yes, there is a text element here. So here you can switch between four types, font types. Okay. So you can explore later this application. So the texts are available, but not all of the font types are available in the TinkerCAD idea. And yes, an SVG files. Yeah. Okay, in the presentation. Okay. Yes, here. Okay. So here in the TinkerCAD you can use SVG files. They are vector graphic files. But you should imagine they are not a picture of a beach or, for example, the other humans. So SVG format is perfect to store, for example, a logo or some geometric object. And you can check or you can download the SVG files from different repositories. For example, the different icons of browsers or any other objects can be available. And for example, you can change your logos or part of the logos to the SVG format. Here on the slide, you can see some converter pages, and you can upload your PNG or EPG files, and the result will be the SVG files, which is for example, a black object with a white background, for example. Okay, so the multicolor is not supported here, so not perfect in 3D design elements. And for example, we have only a sample, and this code was uploaded. And basically, when you export. When you import your SVG file in TinkerCAD, then it will be extruded. So it is similar to the base figure, will be extruded in the space to get cylindrical or so close to the prism in geometric shapes. Okay, and for example, the part of your logos, or sometimes if you use a special font type on your logo, then it is a perfect tool to create similar. Okay, and I don't know. Yes, there are something. Yes, and if you check, we have teamwork for you, and for example, you have. I don't know, seven groups, maybe. So there are 7 different companies here in this student teams, and based on your logos or based on your company names, try to design an object in 3D. And we have some motivations, so I will show you some printed and not printed samples. So here. There are the inputs for you. So create something, design something which promote your company. Okay. And if you check the printed samples on the first act, come here and check it. So for example, this 3D printed QR code with the different colors can be created. So not the QR code and go home, so not exactly the task, but you can create a promotional idea from this. And you can see you can touch it, so the difference between the white and black parts are computed with the layer height. And thus the other objects, and
No. None? Okay. Okay.
so you can go here. So for example, this is a marker point, point replacer, and a marker trolley with our faculty logo was transported to SVG format, and it was
To use it as a pattern. So now it's your turn. You can even do it individually. It's up to you, or you can just create groups, because basically you were working in groups, so there are some students who has the same company. So try to use the logo of your company, which could be 3D printed, or to use any promotional object like cups or anything, which can hold the name or the logo of your company. What you have to take care, of course, that it should be 3D printable, so not anything. And you have learned the basics of some design steps in TinkerCAD. The PDF is available in Teams. Okay, so if you forgot something, how to do it, there are some very complicated things as well in the PDF. So just go to Teams, download the PDF, and you can check everything, how to do it, but what kind of URL you can use, for example, to convert a JPG file to SVG, and so on. So,
button on the surface, and then the button on the bottom. Okay, so
and if you would like to get inspired, you can come here to see some examples, but you can use your own imagination. Okay, so try to design something with the company name or company logo to promote your company in Teams or individually. It's up to you.
and not necessary to use all the parts of your logo. So for example, another sample for you. So this small keychain comes from an event in our university. There is a large event in autumn semester for the new students or fresh students, and this is the name, Open Days, and this is the name is Dexpo, because our University of Debrecen, and in Hungarian it is Debrecen Egyetem, and the initial letters are written, and the full logo has the other Dexpo more letters, but here we create a smaller part, and it was a great gift for the visitors in some years ago. Okay, so not necessary to use the full logo. A part of your logo can be used in this design.
And don't forget that you can use several colors. If your design will be makes it possible to use different colors, or the ones you could touch, this one. In this case, during the design, you have to take care the different widths of different parts to be able to change the filament. Okay, so please think not in one color, not only about the shape, to contain the shape of your logo, but to use some kind of creative way to design something for your company. Of course, we will be here. So during the process, if you have any questions or you need some advice and so on and so on, we are here to help you. So decide whether you would like to do it individually, or you will again form groups and to think together.